this one. So need the 10 more than check whether this is partial. Sometimes in this stop, you cannot terminate. That is the deadlock. So we try to find such a thing happen or not. This one is a simple problem to understand the Banker's algorithm and the state. The problem is when we have the multiple instances for each type of the resource. So it will be more complicated. To do that, looks similar as if we are doing the Banker's algorithm to avoid. We are doing avoidance. We need to check in case something requests. In case you request something to me, then I will check whether this causes a deadlock or not. If deadlock, avoid the request. If no deadlock, then the accept, grant the permission. So to do that, this is a general case of the Banker's algorithm. General case means multiple instances. So like how many available resource instances. Okay. So for each resource type, how many of them? It's a m length of m is number of the resource type. And max is the maximum total. How many need? How many instances are needed to terminate the process? For each process, n represents the process, and how many instances? N by m. Okay. For example, processor 0 need one CPU, 2 magnetic tape, 3 hard disk drive, something like that. Allocation is currently how many of them are allocated. So it's for each process and for each the instance. And then how many need more? To be completed, how many need more? So these are the data structure that we are going to use for the Banker's algorithm. Let's see the example first. This is the algorithm. I will give the 30 seconds to understand this algorithm. 30 seconds. Because you are so smart, you can understand easily. And more. So instead, later you can go back and read the algorithm. Then you will understand. To understand this, actually this algorithm is not complicated. It's the same as what we have done here. Try to complete one by one. Try to find any process, any customer who requests to withdraw the money, give the money, then see, next one, until complete all the process. So, for example, this is the current state of the resource process and resource allocation. How many processes? 5 processes. How many different types of resource in this case? 3 of them. Let's say A, B, C. A has, let's consider A is the CPU. B is the hard disk drive. C is the magnetic tape, and so on. Then A, how many A? 10 of them are available in our computer. And B, how many of them? 5 of them are available, maximum. And C, 7 of them. These are total available resources. Okay? 3 types and the number of instances. So we have the 5 of them. For first one, so allocation. And next, let's take a look at max. Max means to terminate each process we need this, which means P0 needs 7, P0 needs 5 of B, the P0 needs 3 of C to be completed. This is a max need. Okay? Similar, go on. The P1 needs this, P2 needs this, P3 needs, P4 needs this. This is a maximum need to be completed. And allocation means currently, how many of them are allocated? P0 has only 1 of B, right? How many more need? 7A, 4B, 3C are needed. It's a max minus allocation. That is a max minus allocation need. Okay? And similarly, P1 has only 2 of A. Need 1 of A, 2 of B, 2 of C are available. Go on. Then we can calculate the need very easily. Then problem, algorithm is whether, so how many of them are available? So currently we allocate the 2, 3, 2, which means 7. And 10 minus 7 is 3. A are available. It's not used. Similarly, 1 plus 1 is 2. 5 minus 2 is 3. B are available. Similarly, C, 2 plus 1 plus 2, 5. And 7 minus 5, that is 2. C are available. Then, question is, which process can be completed first with this available? You need to take a look at. So let's say that the A, B, C, 3, 3, 2. What time? 2 minutes. So within 2 minutes, we need to complete. Okay, so this is the need. Which process can be terminated first? Which means equal or less than available. So P0 can be? No, it's need 7, 8. So not possible. P1? Yes. P2? No. P3? Yes. P4? No. So P1 or P3 are possible. You can start either of them. If not available, go back to check the next one. But idea is, if the more, the less need is better. You need to take a look at allocation, because after terminate, we need more free the resource. So we can start the P1. So P1, once P1 is done, this allocation will be returned, will be added to the 200. So right now 5, 3, 2 are available. P1 is done. Then check which one will be available. P3 definitely possible, and P4 is possible, and P2 is not yet. P0 is not yet. So either P3 or P4. So we can next P3. Once P3 is done, 2, 1, 1 will be returned. So 7, 4, 3. So in case of 7, 4, 3, P0 is possible, P2 is possible, P4 is possible, anything can be possible. So we can find sequence of process that can be terminated. Which means, is this the safe or not? So yes. Safe means no deadlock. So we can proceed the next step. Okay. So this is a Banker's algorithm. From the algorithm, it's simple, but go back to the algorithm. Then it's exactly the same as what we have done just before. For each, we can find the work and finish, and for each I. Then set up the false. False means it's not terminated yet. Then we need to find the need is equal or less than work, and so on. Then finally we can find. Okay. Then what if this is a real example? So far we talk about what is a Banker's algorithm. So then, what if such a decision will be happen when a process requests something? Okay, currently it's not the deadlock, it's a safe state, but in case P1 requests 1 of A, 0 of the B, 2 of the C. The P1 requests that. Then allocation will be a need will be changed from here. Okay, 1 or 2 is requested. So next 1 or 2 will be here the need. Need 1 or 2. So suppose that if I allow the request, whether that is the safe one, apply Banker's algorithm. So 1 or 2, suppose that take out the 1 or 2. So it will be 0, 2, 0. So 0 to 0, then it's allocated. Suppose that it's a future state. Then run the Banker's algorithm, whether you can find the sequence. If you go apply the same thing, you can find the P1, P3, P4, P0, P2. So which means it's a safe state, no deadlock situation. So you can accept, grant the request. However, why don't you test with this one and this one in your homework? I'm going to ask. Not ask. Why don't you solve the problem on the sketch paper? Only handwriting. So these two cases. Okay? These two cases, handwriting, no printout, okay, by the next class and submit. Okay, 1 page is enough.
So we.
By Monday.
So we're gonna write it and take a photo and then submit it on.
Oh no, just the handwriting with a pencil or whatever, but handwriting only. So solve the problem and submit on the desk at the beginning of next class. Okay? Which means please practice by yourself. Do not copy and paste just your handwriting. So you can copy from your friend, but you will learn how to solve that, at least. Okay? I'm going to allow copy, but the handwriting copy. Okay? Please solve the problem. So these two problems, whether you are going to grant or not. Definitely I'm going to ask the similar, almost the same question in your final. Okay? Sometimes I asking the exactly same one, but only half of them can. So solve the problem with a sketch paper, then with the handwriting, you can copy it from your friend. It doesn't matter, but at least the neatly copy, then you will learn from your friend also. Okay, thank you, and we will see you on Monday. So don't forget, if you want to check your midterm, come by my office on Friday, 11 to 12:30.